Welcome back to Rise Up Learning. Episode 4 of Rates of Reaction is here, and today we are stepping up to A-level and Cambridge level questions. These questions require deeper understanding and precise scientific language, but if you followed episodes 1 to 3, you have a strong foundation. Grab your calculator and notebook. Let's tackle these together. Question 1. A-level. Using a Maxwell-Boltzmann distribution diagram, explain why increasing temperature increases the rate of reaction. The Maxwell-Boltzmann distribution shows the energy of particles. The activation energy is the minimum energy needed for a reaction. Only particles in this shaded area can react. When temperature increases, the entire curve shifts to the right and becomes flatter. The peak moves to higher energy values. Crucially, the area of particles with energy over EA increases. This means more successful collisions per unit time, and therefore a faster rate of reaction. Question 2. A-level rate expression. For the reaction A plus B, C plus D, we have this experimental data. We need to find the order of reaction and the rate constant K. Comparing experiments 1 and 2, B is constant, A doubles and the rate doubles. So the reaction is first order with respect to A. Comparing experiments 1 and 3, A is constant, B doubles, but the rate stays the same. So the reaction is zero order with respect to B. The rate expression is rate beats Ka. Using experiment 1 to calculate K, T rate divided by A equals 0.02 per second. Cambridge question. Catalyst and activation energy. 4 marks. Explain how a catalyst increases the rate of reaction with reference to activation energy and the energy profile diagram. Model. Answer. A catalyst increases the rate of reaction by providing an alternative reaction pathway that has a lower activation energy than the uncatalyzed reaction. On the energy profile diagram, the uncatalyzed reaction shows a high energy hill, representing the high activation energy that must be overcome. The catalyzed reaction shows a lower energy hill. The activation energy is significantly reduced. Because the activation energy is lower, a much greater proportion of particles have kinetic energy equal to or greater than this lower value, as shown by the Maxwell-Boltzmann distribution. Therefore, more collisions are successful per unit time, and the rate of reaction increases significantly. Importantly, the catalyst does not change the overall energy change of the reaction. The reactants and products remain at the same energy levels. Only the activation energy, the height of the energy hill, is reduced. A-level and Cambridge exam tips. Always draw and label the Maxwell-Boltzmann curve correctly. For rate expressions, always determine order by comparing experiments where one variable is constant. Units of K depend on overall order. Learn them carefully. Catalyst questions. Always mention alternative pathway and lower activation energy. Energy profile. Catalyst lowers the hill, but does not change the overall energy change. Episode 5, the final episode, is all about common mistakes and power exam tips across all levels. You do not want to miss it. Thumbs up, subscribe, bell notification, and drop questions in the comments. Keep learning, keep rising. This is Rise Up Learning with Mr. Seeker.